This topic is very, very important as per the organic synthetic chemistry. We will see what is meant by enolate. Introduction मध्ये आपण बघूया इनोलेट म्हणजे काय, पण त्या अगोदर आणखीन एक महत्वाची टर्म या ठिकाणी एक्सप्लेन करतो. व्हॉट इज मीन बाय ऍक्टिव्ह मिथिलीन ग्रुप, व्हॉट आर द ऍक्टिव्ह मिथिलीन कंपाऊंड, आणि मग आपण बघूया व्हॉट इज मीन बाय इनोलेट. ठीक आहे. नाउ लेट अस सी व्हॉट इज मीन बाय ऍक्टिव्ह मिथिलीन ग्रुप. जनरली मिथिलीन ग्रुप आपण कशाला म्हणतोय? सपोज देर इज अ CH2 group, then it is called as a methylene group. Okay, here this is the CH2 group, methylene group, and suppose that methylene group is attached here. In this case, the name of this particular compound is a diethyl malonate. The name of this compound is a diethyl malonate. It is diester of malonic acid, CH2COOH, CH2COOH. This is called malonic acid. Now here that hydrogens are replaced by alkyl group, ethyl group, hence it is called diethyl malonate. Example of ester. Now here that CH2 means methylene group. Now this methylene group is attached from one side by ester group, COO-C2H5 is the ester, while from another side also there is a ester group, and this ester is an electron withdrawing group. This ester is an electron withdrawing group. Okay, now that methylene group is attached from both sides by electron withdrawing group, and hence that methylene group is active. That hydrogen atoms of methylene group are acidic in nature, they are highly active, and hence that compound is also called as the active methylene compound. Now let us see some examples of electron withdrawing group. Here CHO aldehyde group, then C double bond O ketone group, COOH, COOR means ester, cyano group, then halogen. These are the actually aldehyde, ketone, carboxylic group, ester, then cyano and halogen. These are the atoms or group which having tendency to withdraw electron towards itself, and hence that groups are called electron withdrawing group. Actually, what is the role of electron withdrawing group हे थोडंसं आपण नंतर बघणार आहोत, पण फक्त एवढं आपण इथं लक्षात ठेवूया. This is example of electron withdrawing group, and here also that ester, this ester is the electron withdrawing group, and methylene group is attached from both sides by electron withdrawing group, and hence that methylene group is active in nature, and that compound is called active methylene compound. Example is the diethyl malonate. This is the same compound actually, diethyl malonate. Now, why it is active? Why that group is active? What is the role of electron withdrawing group? यामध्ये इलेक्ट्रॉन विड्रॉइंग ग्रुपचा काय रोल आहे, किंवा त्या मिथिलीन ग्रुपला ऍक्टिव्ह का म्हणायचं हे थोडंसं आपण बघूया. मी यामध्ये असणारा जो CH2 ग्रुप आहे, I will show that hydrogen separately. CH2 actually this is the methylene group CH2. Okay, I have written that two hydrogen atoms separately. Now let us see why that methylene group is active, means how that hydrogens are acidic in nature. Suppose this compound comes in contact with base. Suppose there is a KOH or NaOH. Now what happens here? Now this base having ability to abstract one hydrogen atom from the methylene group. मग हा बेस काय करतो? या मिथिलीन ग्रुप मधला एक हायड्रोजन ऍटम तो या ठिकाणी घेतो. दॅट बेस abstract one of the hydrogen atom. म्हणजे हा OH आणि इथला हायड्रोजन यापासून तयार होईल H2O. सायमल्टेनियसली बॉन्ड बिटवीन कार्बन अँड हायड्रोजन, दिस बॉन्ड अंडरगो ब्रेकिंग. या बॉन्डचं ब्रेकिंग होतं, अँड दिस इलेक्ट्रॉन पेअर गोज ऑन द कार्बन. म्हणजे इथला हायड्रोजन आणि OH मायनस इट फॉर्म H2O. आय हॅव रिटन मायनस H2O ऑन द एरो. Okay, now this electron pair, actually this bond undergo breaking, and electron pair goes on the carbon, and that carbon acquires negative charge. Now this carbon acquires negative charge. Suppose there is a negative charge on the carbon, and we know that if carbon having negative charge, then that intermediate is called carbanion, and thus there is a formation of carbanion. This carbanion undergo delocalization. हा जो कार्बॅनियन आहे त्यामध्ये काय होतं? दिस इलेक्ट्रॉन पेअर इज डिलोकॅलाइज इन द इलेक्ट्रॉन विड्रॉइंग ग्रुप. त्याचं डिलोकॅलायझेशन होतं, म्हणजेच दॅट कार्बॅनियन शोज रेझोनन्स इफेक्ट. दॅट कार्बॅनियन शोज रेझोनन्स इफेक्ट. ओके, हिअर actually how that carbanion shows the resonance effect. This electron pair form a pi bond between that two carbon. Here this electron pair form a pi bond between these two carbon. Therefore, to maintain the valency, one of the pi bond, here this pi bond undergo breaking, an electron pair goes on the oxygen. यामध्ये electron pair oxygen कडे जाते. Now there is a pi bond. Here this is the new pi bond. While that oxygen having negative charge, and we get the another resonating structure for the carbanion. This is delocalization. This is called resonance effect, and we get the another structure, and this another structure is called enolate ion. When there is a delocalization of electron pair in the carbanion, we get another resonating structure, and that second resonating structure for the carbanion is called enolate, and this is called enolate ion actually. Okay, now this is just about the resonating structure. Now similar to this, again there is one more type of delocalization. यामध्ये आणखीन एक पॉसिबिलिटी आहे. कसं delocalization possible आहे मी मगाशी दाखवलं. This electron pair delocalize in the upper ester group. Similar to that, this electron pair can be delocalized in the another second electron withdrawing group. या ester group मध्ये सुद्धा त्याचं delocalization होतं, and we get one more resonating structure. And thus, due to presence of electron withdrawing group, that carbanion undergo delocalization, it shows resonance effect. If any species shows resonance effect, then it becomes stable. If there is a delocalization of electron pair, then that species becomes stable. Means here that carbanion is more stable due to resonance effect. हा carbanion कशामुळे या ठिकाणी स्टेबल आहे, तर carbanion हा स्टेबल आहे ड्यू टू रेझोनन्स इफेक्ट. आणि रेझोनन्स का दाखवतो carbanion, तर ड्यू टू प्रेझेन्स ऑफ इलेक्ट्रॉन विड्रॉइंग ग्रुप. म्हणजे मिथिलीन ग्रुपच्या दोन्ही बाजूला इलेक्ट्रॉन विड्रॉइंग ग्रुप आहेत, इस्टर आहेत, आणि त्यामुळे त्या ठिकाणी इलेक्ट्रॉन पेअरचं डिलोकॅलायझेशन होतं, म्हणजे रेझोनन्स इफेक्ट त्या ठिकाणी ऑब्झर्व होतो, अँड देअरफॉर इट इज मोर स्टेबल, आणि म्हणून तो मोर स्टेबल आहे. ठीक आहे, आता मी थोडंसं आणखीन पाठीमागे येतो. या प्रोसेसमध्ये दिस इज द रिएक्टंट while carbanion is the product. Okay, diethyl malonate, this is the reactant, active methylene compound is the reactant, and that carbanion is the product. Okay, and here that carbanion, that product is more stable. This is more stable. Why it is more stable? Due to resonance effect. And thus carbanion is more stable, product is more stable, and therefore diethyl malonate can easily lose hydrogen. म्हणून म्हणजे इथं तयार होणारा प्रॉडक्ट, एक गोष्ट नेहमी लक्षात ठेवा, कोणत्याही केमिकल प्रोसेसमध्ये, इन एनी केमिकल प्रोसेस, सपोज प्रॉडक्ट इज मोर स्टेबल, देन इट्स अ फॉर्मेशन बिकम्स इझी. जर प्रॉडक्ट मोर स्टेबल असेल तर त्याचं फॉर्मेशन इझी होतं. अँड हिअर ऑल्सो carbanion is more stable, therefore diethyl malonate can lose hydrogen easily. त्यामधून इझिली हायड्रोजन बाहेर पडतो, आणि म्हणून त्यापासून मोर स्टेबल carbanion तयार होतो. Why this methylene group is active? Because that hydrogen is acidic in nature. मग त्याला acidic का म्हटलं मी? Because diethyl malonate lose hydrogen. कोणत्याही सबस्टन्सला आपण ऍसिड कधी म्हणतो? इफ इट हॅव्हिंग टेंडन्सी टू डोनेट हायड्रोजन. जर त्यामधून H+ आयन बाहेर पडत असेल, देन इट इज ऍसिड. हिअर ऑल्सो इट कॅन इझिली लूज दॅट हायड्रोजन ॲटम. म्हणजे बेस तो हायड्रोजन घेतो, म्हणजे यामधून H+ आयन बाहेर पडतो, अँड देअरफॉर दॅट हायड्रोजन्स आर ऍसिडिक इन नेचर. अँड thus in diethyl malonate, methylene group CH2 group is attached from both sides by electron withdrawing group. Therefore, it can lose hydrogen easily, and we get the more stable carbanion, and that more stable carbanion is the resonance stabilizer. Okay, and that compound is called active methylene compound. And here, that carbanion is resonance stabilizer, and there is formation of enolate ion, आणि त्यापासून enolate ion तयार होतं. म्हणून आपली जी आता टॉपिकचं हेडिंग आहे, ऑर्गॅनिक सिंथेसिस वाया इनोलेट. मीन्स इन दिस टॉपिक we are going to discuss some of the synthetic reaction, some of the important organic reactions which involve formation of carbanion, which involve formation of enolate ion as an intermediate. And therefore, the name of the topic is the organic synthesis via enolate. This is very important topic because so many synthetic reactions, so many organic compounds can be prepared by using that synthetic reactions, which involve formation of carbanion, which involve formation of enolate ion as an intermediate.